Okay, so here's problem 3 for homework 13. We have a decorative lamp. It's to be hung in the lobby of UHart's Lincoln Theater. The frame is supported by a joint at the wall that cannot support moments, only forces. So that's that O right there. The new lamp has a mass of 450 kilograms, which I believe is a lot. The dimensions are 0.75 meters here and here, 1 meter in this direction, 1.5 over here, and we have this one right here is 1 meter, and this is another 1 meter, and then this is 2 meters right here. So we want to find the reaction forces at O, and we want the tension in each cable. And I've already written out the problem, so my video wouldn't be quite as long as it would be otherwise. And I need to get rid of my eraser shavings. They're starting to accumulate. I have that nice little brush that we got when we in our graphic communications class, right? So let me draw the thing. I'm going to simplify my drawing here. Right, so kind of simplified it a little bit, maybe. So I have this like see-through ruler so I can see whether a line is parallel or not, right? I'll cut it off. Okay. So we're going to have a force that's coming up right there. We're going to have a force that's coming up right here. We're going to have a force that's coming in right in here. See, this almost seems like to me to be a redundant, unnecessary cable, which concerns me. We haven't covered this yet, but it's something called statically indeterminate when you have too many supports. Right, so this is going to be upwards, and I'm going to pick this one in the positive X direction. I'm going to pick this one in the positive Z direction. Is that positive Z? No, that's positive Z. This is positive X. All right, I'll put it that way. Right here, it says I forgot. This is my X direction right over there. Let's see other things. Well, yeah, I gotta need the weight of this thing coming down. So I'm gonna have this weight coming down here. I'm gonna have this force AD, have a force CE, and have a force CF. Yeah, see that? I just don't know if I feel as though that's redundant. We'll see. Here's my reaction at O in the Y, my reaction at O in the Z, and my reaction at O in the X. I select them all by default as positive. Let me declare this as an FBD, and let me give it a coordinate axis here. Kind of did that right. Right there. So here's your FBD. I'm not going to label any of the dimensions. I usually would in other FBDs when we do it in planes. We'll see that soon. Let's see. Things I need to get out of the way. You could write down what the reactions. It's just all going to be right there. It's excuse me. That the R. We know that CF is going to be FCF, and it's going to be negative. How do I know that? It's got to pull in that direction, right? So it's going to be a negative FCFI right there, right? The other ones I got to do a little bit, but it's not quite nearly as much, right? We could write what the position vectors are going to be D with respect to A, right? That's not hard to do. That's just that ZOA right there, right? So that's going to be 2, and it's in the negative, let's see, it's 0 in the I direction. You gotta remember that this is the X coming in this way right here. So it's 0I, and it's going upwards, so it's going to be positive, and it's going up YOD, which is 1 meter, right? So I didn't quite make them look like they were the same right there. But it's going up. And it's going backwards, though. It's going backwards this amount, 2. These are meters. All right, so we could do the magnitude of D with respect to A. And that's just going to be the square root of 3, right? No, square root of 5? I can't remember. 1 plus 4 square root. Yeah, there you go. It's going to be 2.236 meters, right? So our F AD is going to be 1 over 2.236 FAD plus negative 2 over 2.236 K, or 0.4472 FAD J plus negative, this is going to be 2 times that, negative 0.8944 FAD newtons. Similarly, FCE, well, I'm going to start off with the position vector. RE with respect to C. 0. And we are going up 2. But we're going back negative 2. So that should be square root of 2, right? No. 2 times the square root of 2. What? 4 times 2 square root 2.828. Yes, 2 times square root of 2 meters. So we're going to have FCE is going to be, I'm just going to ignore that part of it. I should have written it, and that's okay, I won't. 2 divided by 2.828 FCE J, I'm going to say it again, plus a negative 2 over 2.828 FCE K, or .707, no kidding, FCE plus a negative 0.7071 FCE K newtons. I don't know if we need to put newtons in there when there's still a variable in there. I think when there's a number in there, you put them in there. I don't know. All right, so we're going to need to take moments. Yeah, there's actually quite a few of these, right? We're going to take the moments about O. That's kind of like understood. But let's see what our position vectors are going to be. There's quite a few of them to write out. So we're going to have C with respect to O. And that's going to be, that's not too bad. It's going to be, what is AB and BC is 0.75. So it's going to be 1.5 in the x direction. 1.5 in the x direction, and it's positive right here. So 1.5 I, 0J, and it's going to be z is going to be 2 meters 2 in the k direction. Now we have to go to B, right? So we have where that load is going to be taking place. But we didn't put that. We didn't write down what that was. Let's write it up here. W is going to be negative 450 times 9.81 J. So that's 450, 9.81. So that's going to be a negative 4,415 J newtons. So, and we're going to have our position vector of B with respect to O. It's only going to go 0.75 in the I direction, 0 in the J direction, and I still think it's going to be 2 in the K direction. And then lastly, we have to go for this force right here. So we're going to need an R A with respect to O, and so let's see, trying to figure this, what I'm going to write. That's going to be 0I and 0J, and it's entirely in the K, so it's 2K meters. 12:30 at night. All right, so let's go through here. Sum of the moments about O as a vector equals 0. Shouldn't be too painful. Let's start with the first one here on the left. We have the position vector at A, 0, 0, 2. And he is going to have FAD is going to have 0, point 4472 FAD and negative 8944 FAD. Let me get these so that they're on top of it. I might not be able to make it all onto this one page. Okay. Then we have this force. I. All right, so let me see where the position vector is for B. It goes 0.75 and 2, and I have a 0 here and a negative 4,415 and a 0. And I needed a J. Sure, there's an I. That's how tired I am. All right, and continuing on, let's see. We have, let's go for FCE. That might need to take up a little bit more room. We're going to go to, we have the same position vector for both of them. This is going to be 0, 2, and negative 2. 0, 2, negative 2. And it's going to have a 0x, right? Yeah, it's going to be that. Is it going to be, what's this one right here, right? That one. .7071 FCE and negative 0.7071 FCE. And I wish I had Started a new piece of paper, like I tell people to do. Because I have one more force, but luckily he's a short force, right? He's just this guy. I just don't know if it's going to do anything. And I drew him wrong. He should be in the negative k direction. I said that wrong here. Glad I caught it. So let's see if I can squeeze this into the corner of the page here, which I shouldn't do, right? Its position vector, same one we just did, 0, 2, negative 2. And here it's 0, 0, negative f, CF. And I'm thinking that I messed up. I still think that it's an unnecessary cable and could therefore cause us to have redundant supports. I don't know. Let's see. Maybe it doesn't do anything. So this is my 6th piece of paper. This is a long homework assignment there. Okay. I need to make homework assignments shorter. You heard it here first, kids. Well, I shouldn't call you kids. That's condescending. I hate people. I hate condescending people, so I don't want to be one. All right, so let's start with I. Ooh, we have an I. We have an I. An I for an I. So we start with 0. We have minus 2 times 0.4. I can't read that now. 4472. FAD. All right, so here's a J. Let's have a J. Boom, boom. We got rid of the J's. Yay. How about a K? Boom, boom. Got rid of the K's. This one only causes an I. I guess that makes sense. I mean, if you're looking at this cable only causes a moment about here. It doesn't cause a moment about Z, doesn't cause a moment about Y. Yeah, I buy that. Okay, let's go to the next one. All right, so here, bracketology. We take the I. Oh, we have one for the I here. All right, so we have plus, and that's going to be that guy minus that guy, right? So it's going to be 0 minus, but now we have 2 and a minus 4415 right there, right? And that makes sense because that too, that's the weight, right? So the weight is going to cause a moment about the x-axis as we've drawn it, right? This weight causes a moment about this axis right there. It's also going to probably cause a moment about the z-axis, but not a moment about the y-axis. So we take a look at our j's, and we don't expect to get anything. And we see we have got zeros each of the crosses. Okay, you go to k, that right there. So we get that. Oh, yep, that and that. Right. So for the k's, we get a plus, and we're gonna have a 0.75 and negative 4415, and then of course that one's okay. So we have a k. Boom, boom. Now let's go to this next guy right here. So he's another cable, and let's just bring him down to the next level. And we see the I's. Ooh, we have some. Well, we have 2 things in the I direction. Interesting. Yeah. Surprised. Why don't I have two things in the other one? I guess I'm taking it about O. That's why. All right. So we have a 2 times a negative 0.7071 FCE. And then we have a minus, but then a minus 2 times 0.7071 FCE. That looks like someone's going to count each other. No, that like cancels itself out. Tell me that doesn't cancel itself out. This is negative. That's weird. Wait a minute. Pause the video. Okay, so first I got something wrong here. This was supposed to be for C. So this should have been, both of these should have been, I don't know where I got that 2 and that negative 2 from. Yeah, that was supposed to be, I'm just tired and I was messing up, and I think I just looked up somewhere, like right up in here. But we need to get C with respect to O. So it needs to be this one right here. So it's going to be 1.5 and 2, and they're both positive, and it should be for both places. 1.5. I don't know how many other places I might have made a mistake because of that mistake. Right there, right? We're recording though, right? We're still recording. I think we're still recording. All right, so that's why you do this in pencil, man. 1.5 and 2. Yeah, and they don't cancel each other out. That's good news. Well, that's engineering for you, man. You gotta, I keep calling you man. Don't call you man. It's not right. Engineering, gotta like try to think your way through stuff. Can't go through the motions. All right, so now we're gonna go J. So remember, this is gonna be minus this there and that one to there. Wait, okay. Well, we're good. No J's. Makes sense. It wouldn't be about any J's, right? Nothing going to spin around that with that vertical axis. And now K. Boom, boom. Nothing about K, huh? Yeah. Really kind of surprised. There's nothing about K. Should be something about K. That and that. Yeah, because I did it wrong again. I did it wrong. This should be 1.5. This should be 0. 1.5 and 0. I swear I should be falling asleep. I should be asleep right now. All right. This is just to prove that I don't like play with the solution manual. I don't like try to trick you. These are difficult for everyone. All right. So let me start with I. That one and that one, that one and that one. Okay, so I have a 0 here in this one now, but it's going to be minus 2 times 0.7071 FCE. Gotcha. I. Take a look at J. We actually do have one around J. That's surprising, but I guess not surprising. No, okay, I can picture that now. All right, so that one times that one minus that one times that one, but this needs to be minus, remember? You gotta take a minus onto this one, so that's always a fun adventure. 1.5 times a negative 0.7071 FCE. J. And then for a K, we're going to have, yep, that, and cross with that. Okay, so we did have a K. We did have some amount of K. I thought so. Of course. I'm tired, so I don't know. All right, last one. And this seems like my redundant one. I don't know if it's going to matter. Let me try it about I. Boom, 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 boom. Don't do anything about I. I tried it about J. Oop, this one has about J. Remember, it's going to be negative, right? So negative 1.5 times a negative FCF J. And then lastly, is there one about K? Boom, 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 boom. Nope. So we have ourselves some equilibrium equations to mess around with. Let's try I's. Do the I's have it? We got ourselves negative. We got a 2 times 0.4472. And it's negative. So we got a negative 0.8944 FAD. All right, so we have a negative. Ooh, I don't like this. Okay, I got that. Okay. So we got a negative. So we have a plus 4415 times 2 should be 8830, right? 8830. More I's. Oh, we got this guy. Minus 2 times 0.7071. I could do that. I should be able to do that, right? Negative 1.414 FCE. And that's it. Okay. So that's going to be like equation 1. We got J. So it makes me nervous. Now this and that. Huh. So I'm going to have a negative. So it's a positive. 1.5.7071. So I have 1.061 FCE. And then we had this guy. And this is kind of messed up. Oh man, this is messed up. Because that's negative. That's not good. One of these ropes is going to have to be a negative. It's going to have to be a rod. That's interesting. You can't push a rope, but we're about to try. Let me double check all my minus signs. So minus. All right. What about this guy right here? He was for I. Yep. Yeah, this problem, I don't know. This is a little messed up here. You see the problem there is that one of them needs to be negative now. There's no other J's involved. Unless I missed a J somewhere. And I don't think it did. Did I have anything where the weight would cause a J? I don't think the weight's going to cause a J. It couldn't. There's no way they could go. Yeah. That needs to be a rod. Maybe that's the lesson to be learned here? I don't know. I think I could try to find where the original problem came from. Let me look it up. Maybe they phrased something like, would you need to replace that with a rod? Now looking at the thing, I kind of think you have to. I don't know. Okay, anyway, let's see. Let's look at the K's. The K's have it 0.75. Let me see. I've been calculating them this time, right? 0.75 4415. And so we get, and this is a negative, so we get a negative 3,311. And okay, this one here, that's the only one that got the K's. No other K's. So plus 1.5 times 0.7071, boom, 1.061 FCE. We can find FCE. Therefore, we divide and get 3,122 newtons. Therefore, we can go back up to the top right up here. Back into 1 up above. And for FAD plus 8,830 minus 1.414 times 3,122 equals 0. So hopefully, yeah, that'll work out. 1.414 times 8830 divide by 0.8944. So we get FAD is 4,937 newtons. Ooh. Ouch. That was the table leg on my knee. And then this last one right here, we would find that we get 1.061 times 3,122 and plus 1.5 FCF equals 0. FCF is equal to negative 0.61 3122 times 1.5 divided 2,208 newtons. This should be compression. All right, but let's do the rest of it. Sum of the forces equal to 0. So let's take everything we know here in the I direction. We got ROX, and in the X direction, do we got anybody else? Do we have anybody in the X direction? This doesn't have any. This doesn't have any. No. No x direction. That's good. In the y direction, R-O-Y, Roy. Let's see. We got plenty, right? First, let's see. We should write this out. We should write it out this way, right? We should have F. No, I'll write it as the reaction first. RO plus F AD plus F CE plus F CF plus W equals 0. That's a lot of things to write. All right. So in the y direction here, we got FAD, which is 4937, but as a vector here, we took 0.4472. And that was positive, so 2208, which is a familiar number there, huh? Look at that. And then FCE, that was our 3122, and CE should be 0.707 times that, 0.7071 times that, and we're getting the same numbers. But was it negative? No, it was positive. 2208. This is weird. Getting all 2208s. It's like coming up little cherries or something. A slot machine. This guy right here, and he's entirely in the K direction, so we don't have to worry about him for this one. And this one's entirely in the Y direction. And he should be the negative 4415. So even 4415. Oh wow. That's nearly going to come out 0. Why? And then let's come out in the Z direction right here. We got all kinds of things in the Z direction. Okay, it makes sense, I guess. Now that I'm looking at the thing, that the thing has to be in compression, because we're going to get for AD here. AD is going to be the 4937, but going to be multiplied by negative 8944. So I guess I'll put them in as a negative here. Negative 4416, which is coming out to the same numbers. What's going on here? I picked a doozy. All right, and then we do CE. CE is 3122, and C, it's a negative. That's the 0.707, 7071 times, and once again, negative 2208, right? And then we have to go this last guy, and okay, because he's going negative, right? Because we got a negative value, we got to put in the positive one for him, right? We could enter in this and then put the negative number there. It would be a positive, right? So we're going to go. It's going to be plus our 2208, which we recognize is 1/2 of that thing right there, and then there's nothing else. So we're going to get for our RO 0I plus 0J plus and 4416. And F, let's see which one we're going to go first. AD is 4,937 newtons tension. F, CE, 3,122 newtons tension. And FCF is 2,208 newtons compression. All right, questionable result. But I will try to do a little research and find out what it is. So there you go. This was a really long problem. This was 41 minutes, and it is 1 o'clock in the morning.